Okay, the start of the second section, natural log function integration. Well, we just learned in the last section that the derivative of the natural log function was stuff over stuff. So the derivative of the natural log of x was just 1 over x. Well, we learned in the previous chapter that we know that the derivative and the integral are inverse functions, they're opposites of each other, right? So if we know the derivative of the natural log is 1 over x, well, therefore the integral of 1 over x is going to be the natural log. All right? So to use that, we can move on down here. You know, log rule for integration, here's broken down in a nice little theorem for you. All right, the integral of 1 all over x dx equals natural log of x plus c. All right, and again, we can still do our u substitution, and that's what number 2 is showing you there. All right, because du equals u prime times dx, so this part right here is what I'm saying. The second formula can also be written, so if we notice, what this is showing you is saying, if we notice a pattern, if we notice that the derivative of the bottom is on top, we know that integral is going to be the natural log of u. All right, so the bottom. So basically it's saying, if we realize that the derivative of stuff is up top, we know that the integral is just going to be the natural log of the stuff right here. Okay? So it's a pattern we can look for. If we look at example 2, all right, we realize that the derivative of x is just 1. Well, we can make this, we can pull out a 2 to make this function look like 1 over x, right? We can pull out a 2. That's the same thing as the integral of 1 over x dx. We can pull out a 2 like that. All right, so we know that the integral of 1 over x is the natural log of x. Well, let's not forget about our 2. We'll put that out front. All right, so the integral of 1 over x is natural log x plus c, right? All right, well, we know from natural logs that we can go ahead and we can bring this 2 and we can put it as an exponent up here for x. So we'll say the natural log of x squared plus c would be the integral of that function right there. All right. Another quick example, and we'll have a nice little short video here. All right. So as you notice here, if I take the derivative of the bottom here, all right, I'm just gonna get 4 on the bottom. Well, we can make this equal u, I guess. We can make this equal u. All right. So u equals 4x minus 1. So what I can do is I can say that du equals 4, right? 4 dx. So then dx equals du over 4. So what we need, in order for the derivative of this function on the bottom to be up top, this would have to be a 4. So we can make that, as long as we make this a 4 up top, if we make that a 4 up top, if we multiply the entire thing by a 1/4, so in theory these would cancel out, right? So basically that we didn't change it at all, but we, on the inside of the integral, we multiply on the top, became a 4, and the outsides we're taking it times a 1/4, so it canceled each other out. Now, what I have is I have the derivative of the top, or the derivative of the bottom is up on top. All right. So I was showing you how that works there. So we pulled a 1/4 out now. So now we can say when we take the integral of this, it's going to be 1/4 times the natural log of our stuff, which is 4x minus 1 plus c, right? And that's all we need. I mean, we could bring that up into the 4th power, but we can leave it like that if we want to. So nice little short video for you, and we'll see you in class.